All right, we're trying to decide, is this a convergent or divergent series? Well, looking at this integral, it appears if we just replace the n with an x squared, I think we can integrate this one and decide whether or not this is convergent or divergent by the integral test. So we got to figure out what's the antiderivative of 1 over x squared plus 1. This may look like one of those substitution ones, but I don't think it's quite going to work here, because if we do our derivative, we're going to have that 2x, which we can't get rid of that x. However, think about this one. What derivative did we have? Where if we took the derivative, we ended up with 1 over x squared plus 1. That one was inverse tangent. So this one is inverse tangent or arctangent of this one. So our antiderivative here is the inverse tangent of x, and then we would be evaluating this one from 1 to infinity up here, because that's our limits. So we're evaluating from 1 to infinity. Well, we can't really evaluate at infinity. So what this is going to turn out to be then is, what's the limit as some other variable, let's use t, approaches infinity of our inverse tangent here of x from t to 1. So now let's plug in both values here. We're going to do what is limit as t approaches infinity of the inverse tangent here of t minus what's the inverse tangent of 1. Well, let's start with the inverse tangent of 1. We should be able to use our calculator to figure that one out. So if we go on here, let's do inverse tangent of 1. We get this value. Now remember, inverse tangent, that means we're finding an angle here. If this is in radians, pi is included, so let's divide out our pi here and see what we get. 0.25 or 1/4. So if we put the pi back with that, looks like this is an angle of pi over 4 in radians. All right, what about our other one? Well, what's the limit as t goes to infinity for inverse tangent? We could look at this one by graphing. So let's graph out inverse tangent here and see what we get. So I'm going to graph out inverse tangent of x. And make sure you're in radians when you graph this. And I'm going to graph this on our standard graph here. So here's the graph of this one. So as we go to infinity, if we were to trace or go to if we're going to our right here, what's this value? Well, you can see it's increasing here. By tracing it, it might take us a while to get out there. It might be better to look at our table as we get very large here. So I'm going to go to table settings. And let's start our table at, I don't know, 10,000 and see what we get. So if we do that, now go back to our table. You can see 1.5707 is what we get. Again, that is including pi here. So if we do 1.507 and divide out our pi, because it's in radians, what do we get? Well, oh, I think I might have entered this wrong. Let me go back to our table. 5707. Okay. So let me try that again. 1.5707. And if I divide this by pi, you can see I get something very close to 4.9999, which is very close to 1/2, which it's trying to do. It didn't give us enough decimal points on that table to see that, but this is approaching pi over 2. So the limit as we go to infinity of this approaches pi over 2. And so if we take pi over 2 minus pi over 4, that should be the same as pi over 4. So this one is convergent by the integral test, because we got this to equal a finite number. So anytime you get a finite number, this is convergent by the integral test. All right, let's try another one here. Determine whether this series converges or diverges. So again, I think we could replace this integral with a, or this summation with an integral where we replace the n's with x's and then try to figure out what the integral would equal. This one, I do believe, whereas last one, substitution didn't quite work, this one I think we can. Let's do a substitution for natural log because derivative here would be 1 over x. And we have a kind of a 1 over x there. So this would now become the integral of, this is getting replaced by u, our 1 over x dx is kind of right here. If I just rewrite this one here, this would just be like this, and so our 1 over x dx, all that becomes our du. So this really just becomes this, okay? So what's the antiderivative of that? It'd be 1/2 u squared here. Let's substitute back in because I don't want to change those limits. So this would be the same as 1/2 natural log x squared evaluated from here to here. And we can evaluate at infinity. So again, I'm going to change this to a limit. Let's use t again. And we're going to end up doing the limit here as t approaches infinity. So whatever this equals now, we can see if it's going to be convergent or divergent. So this is going to be now our limit as t goes to infinity of 1/2 natural log of t squared minus 1/2 natural log of 1 squared. Natural log of 1 here, I should have had all that in parentheses. Natural log of 1 we know is 0, and so all this just equals 0 because a half times 0 is going to be 0. What about our limit here? What does this do? Well, what's the graph of natural log going to do as you go to infinity? If you graph out natural log here, we've seen this graph before. Looks like this. Just is going to keep increasing and increasing and increasing on the right hand side there. So this is infinity. Well, that means this is going to keep increasing. So is that a finite number? Nope. So what we see here is this series diverges by the integral test. So if you don't equal a finite number, that's going to be a divergent one. All right, let's have you pause the video and see if you can determine this one again using integral test for this one. So set it up as an integral and see if you can solve this one out. All right, let's see how you did on this one. So this looks like a substitution one. I did rewrite e to the x squared in the numerator as e to the negative x squared, and then I set my u equal to that negative x squared. If you just did it as u equals x squared, it should come out the same answer. But if you do the substitution, then our integral just becomes e to the u. There is this extra negative 1/2 that I wrote in front there. Antiderivative would just be e to the u from 1 to infinity. I changed that to a limit so that we can evaluate this. Also make sure you do substitute back in for your u. And then if we plug that in, now we're doing what's the limit as t approaches infinity of this at t minus this at 1. And simplifying here, our two negatives end up being a positive. I move this back down to the denominator as e to the first power. Same thing here, I move this down as e to the t squared. Well, if you do the limit as that goes to infinity, this is going to get very large in the bottom here. So 1 over a very large number that's approaching 0. And then we'd have plus the 1 over 2e, which means this is approaching a finite number. We have a convergent series here by the integral test.